Hey there, Seahawks, it's Miss Adams, and in this video we're going to go over basic set notation. Alright, so you've kind of already seen me using some of the probability notation, and we're going to get a little bit more in depth with when we combine more than one event. Alright, so we have two sets here. We have set X, which has the elements 2, 3, 5, 12, 8, and 15, and we have set Y, which includes the elements 12, 13, 14, 15, and 16. I'm going to go ahead and throw those into the Venn diagram that I have. So I have this box around my two circles that overlap. That box is everything in my universe. And then I have X and I have Y. So when I put my values that overlap, or 12 and 15, they're going to go in the middle part where they overlap my circles. So something that's in X that's also in Y goes in that section. Then I'm going to put all the other numbers that are in X in just the part that's in X but not overlapping with Y. All the numbers that are in Y but not in X in that section. I didn't have anything else in my universe. If my universe had been like all integers between 1 and 16, then anything that was not a number listed could be in my universe. But I didn't have that as a rule. So I don't have anything else that's not in X or not in Y. Alright, so my intersection, which is usually used with the word and, is going to look like this. X and Y. X intersect Y. So it kind of looks like a U, but it's upside down. That's the intersection sign. So anything that's an X and in Y is meeting that condition. So this would be the set containing 12 and 15. Something that's an X and in Y. That's what that means. Union, or is, it looks like a U in between them. So it's X or Y. So anything that's in X or in Y, okay, is everything in X and everything in Y. Okay, you don't want to count the stuff that is overlapping twice. All right, so you want to make sure you only count the 12 and the 15 one time. So you don't want to copy all of X and all of Y because some of them are repeated. So you want to get rid of those repeats so that you don't write them two times. So if you make the Venn diagram, then you're basically just copying all the numbers that are in X and Y circles and in the overlapping part. Relative complement is the difference between sets. Okay, so relative complement of Y and X is written as X and then the slash, but it's more of a forward slash Y. So X, it's really X minus Y. You're taking everything in X and you're minusing everything in Y. Okay, so if I take everything that I have in my X and I get rid of any numbers that are also in Y, that leaves me with just 2, 3, 5, and 8. What you can see is all of the blue numbers there in my Venn diagram. They're in X, but not Y. So I took X and I subtracted out anything that they had with Y. If I do Y and then the forward slash X, that means I'm going to do Y minus X. So it's going to give me anything that's in Y that's not in X, which is 13, 14, and 16. All right, the absolute complement means not in that set, and it's either X prime with a little dash or X with a C as like an exponent. All right, so X prime is not in set X. So everything that's not in set X. Okay, so if it's not in set X, then I have to get rid of all the things that are in set X, which leaves me with 13, 14, and 16. Okay. All right, so here is just all of the different notations and how they look as a Venn diagram. So you can see the intersection, you can see the or, you can see the absolute complement, you can see A and the complement of B complement, A complement and B, A or B complement, so not in B. Remember, complement is not in. So then the next one, A complement or B, so not in A, or it can be in B. And then I have A complement or B complement, which means not in A or not in B, which is basically the complement of A and B. So it's not in A and B. It's not in the overlap. And then A complement and B complement is not in A and it's not in B. or the complement of A or B. All right, so that might be helpful to refer back to. All right, here we have a challenge problem. So we have three sets, A, B, and C, and we want to find this big, huge mess. So to start with this, we're going to start on the innermost piece first, just like you would if you were solving or evaluating an expression. You want to start with the innermost parentheses first. So B minus C, and then take the complement. So I'm going to do B / C, which is B minus C. Everything in B, take out everything in C. So I'm going to take out everything that B and C have in common. So I took out all the elements of C that were in B, and that leaves me with 0, triangle, and 3. And then I want the complement of that because it has that little prime, that hyphen mark thing. So I'm going to take everything that in the universe that is not 0, triangle, or 3. So B / C prime is everything but 0, triangle, and 3. So everything that I have there except for 0, triangle, and 3 is fair game. Now I'm combining that with A. So it's A intersection, which means and. What do they have in common? So A and everything but 0, triangle, and 3. So I'm looking at A, and I'm getting rid of everything that's 0, triangle, or 3. It does have a 0, or it has a triangle and a 3. So that leaves me with 1, 17, 21, pound, 9. Okay. Now I'm doing A / all of that. So A minus all of that stuff I've selected. So I'm taking everything in A, and I'm subtracting 1, 17, 21, 9, and hashtag, or pound sign. And that leaves me with just the 3 and the triangle. Now I have to figure out what is B and C. So B and C is everything in B that's also in C. B and C, what do they have in common? Where would they intersect? So 11, 2, and 9 is what they have in common. So that's B and C, or B intersects C. Now I'm going to combine the part in orange with the part in light blue, and it's an OR. So 3, triangle, or 2, 9, and 11. Since it's OR, it can be any of those things. They don't have anything in common, so I'm just going to write all of the elements, 2, 3, 9, 11, and triangle. And that's my answer. All right, go Seahawks.